in here, question 8. Question 8 shows ultrasonic pulse introduced into the wall of 100 mm thick nickel pressure vessel. Return to the transducer in 2.4 times 10 to the power minus 6 seconds. So you can see here what equation we are going to use in ultrasonic is for solving these problems. Whatever I shown to you is velocity is equal to the velocity is calculated as distance divided by time. This is the equation that we know we studied in applied mechanics, etc. But how much distance is traveled by ultrasonic waves? If you take, for example, a material, and this is the depth of the material, then if this is the depth, how much distance how much it travels? If you look at it, it hits and then goes back. So the same, if you use a transducer here, the ultrasonic wave will travel d, then comes back to the same crystal d plus d. So the total distance traveled by ultrasonic wave is 2 times d, the depth, divided by t. T is the time traveled, the time taken by the ultrasonic waves to travel from the top to the back wall and then comes back to the same point. So this is the basic equation used for solving these questions. So what we have is we have an ultrasonic pulse introduced into a wall of 100 mm thick. So the material has a thickness of 100 millimeter, as I explained before, 100 mm. It is a nickel. So the material used here is nickel. So and it returns. So what are the things we have? The thickness of the material is given as 100, and the time taken to receive t equal to 2.4 times 10 to the power minus 6 seconds. So the time is also given. Now the question is, this we are getting a signal. Is this signal we are getting from the back wall? Opposite wall means back wall. This is called opposite wall or back wall. Is it from the opposite wall or back wall, or is it from a defect? Discontinuity means what? Discontinuity means defect. So is it from opposite wall or is it from discontinuity? This is the question. If it is from a discontinuity, yes, if it is from a discontinuity, how much is the depth? How far beneath means how much is the depth of the defect? How much is the depth of the defect? So this is the question given to you. So as I explained before, if how far beneath the surface of the wall is the discontinuity. So what is the, I think the question is clear to you. Before that, I will explain again. What we have here in this question is, we have an ultrasonic pulse. We have a material. That material is nickel, and the thickness of the material is 100 millimeter. This material we are going to test by ultrasonic. For example, it is a, let us say it is a pulse echo technique. It is pulse, it is written here, pulse echo. So it comes, the ultrasonic waves will come, it strikes other side and then goes back. So how much is the total distance? We have velocity, distance by time. This is the equation used for calculating it. Now the question is, we have the depth, the thickness of the material 100, and the time is given as 2.4 times 10 to the power minus 6 seconds. Is the signal, you are getting a signal, for example, the first signal you will get here, which is called initial pulse, initial first one, You know from where the initial pulse is coming. Initial pulse is coming between the transducer. We call it as a crystal or a transducer and the material from here. So initial pulse is obtained from here between the crystal and the transducer, and we are getting a signal after say 2.4 times 10 to the power minus 6 seconds. So we are getting a signal. This signal, is it from the backside opposite wall or from a defect? This is the question. Hope that the question is clear to you. How many of you have understood the question? Is the question clear to you before I proceed? Yes. Yes. If the question, yes, if the question is clear, then let me see tutorial 2 here. Here we have a table. I just want to attach this table here. In nickel is there, nickel, yes. So this is our question here, and I will paste a column here. So this is basically we have a table here. This is constant. You can see ultrasonic velocity for aluminium is 6.25 times 10 to the power 6 meter per second. What does it mean? It means that the velocity, ultrasonic velocity or sound velocity through any material, it is constant. For aluminium, it is constant, nickel, magnesium, different velocities, but for each material, it will be constant. So we have nickel here. How much is the velocity for nickel? 6.02 times 10 to the power 3. So come here to our question. We open the question. Now we are going to solve it. The velocity from the table for nickel, it is 6.02 multiplied by 10 to the power 3. And the time is 2.4 times 10 to the power minus 6. Let us substitute it in here. Velocity equal to 2d by t. So velocity is 6.02 times 10 to the power 3 time equal to 2d by t. T is 2.4 times 10 to the power minus 6. How much is the value of d? Can you calculate it and tell me how much is the value of d you are getting? Anyone has a calculator? If you could calculate and tell me how much is the value you are getting.
Yes, doctor, 1 minute. Doctor, it will be 7.4 multiplied by 10 minus 3.
Yes. All are getting the same value? Yes. 7?
Yes, doctor.
7.2.
Is it 7 or 72?
7.2.
Yeah, tell me the value. 7.22 times 10 to the power?
Minus 3.
Minus 3.
Minus 3.
Yes.
Yeah, okay. So
this
we are getting, sorry?
This is meter, right? Distance.
Yeah,
unit.
Yeah, this is given in meter.
Yep.
The answer is given in meter. Okay, this answer is given in meter. Okay, so you how much is the, if you convert it into millimeter, how much you get in millimeter? In millimeter, you are getting it as 7.22 millimeter. Am I right?
Yes, doctor.
Yes, this is just a conversion. You calculated, you told me the value which is in meter. I just converted meter to millimeter. So if the D is 7.22, will this be correct? Because if it is from, look at that, we have a material here. The material has a thickness 100. If we get D as 100, that means definitely it will be from the back wall or opposite wall, correct? What does it mean? What is the meaning of this 7.22?
Defect.
Anyone?
Defect.
Definitely, yes, very good. It is from a defect. If we get D100, what does it mean? If we get
The
D100,
opposite wall. The opposite
yeah,
wall.
it is from, yeah, it is from the back wall or from the opposite wall, we can say. But if we get less than 100, like 7.22 millimeter, it means that there is a crack at a height of 7.2 millimeter. Is that clear? So what is the answer here? Is this time lapse caused by opposite wall of the vessel or by a discontinuity within the wall? The answer for this is number 1. It is not from opposite wall, correct? It is not from opposite wall, and it is from a defect.
Defect.
Now the question 2 is, if it is from a defect, how far? How far means what is D? How far beneath means what is D? So D we can calculate. We already calculated D, 7.22 millimeter. This question, is that clear to you?
Yes, doctor.
Yeah, it is direct substitution and direct calculation. So the question is whether the signal you are getting is from the discontinuity or from the wall. So what you are getting here is how it appears. I will show you how it appears. The first signal will be in here. This is the first signal in 0. Second signal will be a crack signal. Signal will be like this. Is that clear to you? So this is 2 times minus 6, 2.4 times 10 to the power minus 6. What about this? Can anyone calculate and tell what signal, at what time you will get a signal from the back wall? This is the material, right? This is the signal from back wall. After what time t you will get a signal?
We can calculate it.
We can calculate it. How?
Yeah, we have T and we have D.
2 times 100 divided by T. What is T? We need to calculate.
2.4 times 10.
Yeah, velocity is how much? Velocity is 6.02
Zero.
times 10 to the power 3.
Yes.
So can you calculate how much is the T here? Anybody?
33.
Yes. If you write in 3.33, how much it will be?
Sorry.
Okay, 0.33 times
10 to
Which
the
is
power minus 5.
just 0.033.
0.033, doctor.
Okay, 0.33. You have used 10 to the power 3 here, right?
No,
Okay.
no, doctor. No,
No, no.
You didn't use 10 to the power 3 here. It is there.
Yes.
You have to use that and see how much. So this multiplied by something, right? 10 to the power. So here
Yes,
6.02 times 10 to the power 3 times 2.4 times 10 to the power minus 6 divided by 2. So this is the final answer.
Yes.
Yes, doctor. 0.033.
Okay. So if in any of the question, if I ask you to sketch, what you will do? You will sketch the first one as 0 initial. Initial is between the transducer and the surface. Second one is from the crack, and third one from the back wall. So you can write the time here. The time is here 2.4 times 10 to the power minus 6 seconds, and second one here 0.033 seconds. This is how we sketch signal coming from ultrasonic waves. Shall I proceed? If it is clear, then I will proceed to next question. Any doubts? Any clarifications? If it is okay, I can proceed.
Yes, doctor. Okay.
Okay. See here. Now we have a question here. Determine the signal you expect to receive when an ultrasonic. So I can even I can write determine and sketch. So determine and sketch the signal you expect to receive when an ultrasonic pulse passes through a sandwich. Look at that, ultrasonic sound waves through a sandwich structure composed of 4 mm thick aluminium surrounded by 2 layers of 2.5 mm thick nickel. So here you have a sandwich structure. So this sandwich structure consists of 4 mm aluminium surrounded by 2 layers of nickel. So how can I draw it? I will draw first aluminium. Okay, this is which one? Aluminium. Then I will draw nickel on the top, another layer of nickel on the bottom. See here, you have nickel here, you have nickel here, you have aluminium. Now you know the values, the thickness of this. How much is the thickness of aluminium? Thickness is 4 millimeter.
4 millimeter.
Yeah, thickness of nickel, how much? 2.5 millimeter. Here also 2.5 millimeter. So you have all the values now. Now can you determine and sketch in this case? You don't have any other values here. Now you are using a pulse echo test. For example, this is the transducer. So from where you get the signals? How can you sketch a signal in terms of time? So you have to write in terms of time. So how you are going to get a signal from this? I think the question is clear to you. So with respect to time, how I can draw a signal? The first signal will be from the interface. See, this is the first signal from 0. From where? That is from here. This is from the, we call it as interface. Okay, first signal from interface. So this signal, when ultrasonic waves, it reflects here itself. That is the first one. But when it travels, it hits the interface here, nickel aluminium interface, and then some part will come back and some part will proceed. So some part will come back here, some part will proceed. So if it comes back, you will get a signal here. That signal is from nickel aluminium interface. What is nickel aluminium interface? This is nickel aluminium border or interface. So the remaining percentage of ultrasonic waves will proceed and hit aluminium nickel interface, and then after hitting aluminium nickel interface, it comes back to the transducer. So you will get another signal here. That signal is from aluminium nickel interface. Again, some part will come back and some part again will proceed to hit the back wall. And then after hitting the back wall, what happens? It comes back and collected here. So here, again, you are going to get another signal. And that signal is from, I can write, it is from the nickel, or I will say back wall. So as you could see here, how the signal is produced, signal produced from initial, which is the front wall. Then the signal strikes the nickel aluminium interface, Then some part will reflect back or come back. The other remaining amount will proceed and hit aluminum nickel interface and reflect back. Then the remaining will proceed and get reflected from nickel, which is the back wall. So this is the we call, in technical terms, we call it as front wall echo. This is called an echo because it's a signal, front wall echo, and this is called as a back wall echo. Back wall echo means the signal coming from the back wall. Now this is how we did the sketch, but we didn't determine the time. So we need to write the time. Definitely here the time will be 0. What is the time here? What is the time here? And what is the time here? At what time or how long will take the ultrasonic waves to hit nickel aluminum interface and come back? How long will take the ultrasonic wave to hit aluminum nickel interface and come back? How long will take the ultrasonic wave to hit the back wall and come back? This we have to write here in this problem. The question, is it clear to you?
Yes, doctor.
That means I can proceed.
Clear.
There is no problem in it, right?
Yes.
So
Doctor,
how? Yes.
the first
Doctor,
signal will be from the front wall to the border of nickel, the first layer of nickel.
Yeah. The first signal, whenever you use, there will be some reflection from the top surface itself. We call it as front wall echo. From the top surface, any material testing using ultrasonic pulse echo inspection method, first echo we call it as, we also call them as initial echo. This will come from the front wall or top surface of the material. That is the first echo. Then the second one, as you see here, this is the interface. So this signal or echo comes or produced, ECH echo produced, whenever there is a change in medium. Change in medium, I will write change in material. For example, if when ultrasonic waves are produced, first is it passes through air or couplant, then it enters. So there is a change in medium there itself. That's why we get front wall echo. Then the first echo, then the second one will be from the nickel aluminum interface. That means from nickel, from back wall of the nickel, we can say. But it is nickel aluminum interface. Then back wall of aluminum, we call it as aluminum nickel interface. Then the back wall of the complete structure. Is that clear?
Yes.
Yeah.
Thanks.
Yeah. Now, how do we calculate it? How we can calculate this velocities? We have the velocities given there in the question. How much is that velocity? Let us write them. Let us mark them. What we have here is we have aluminium given. We have nickel. Remember, aluminium is given, nickel is also given. So let us go back to the question. And let us calculate, let us use our equation. Our equation is velocity is 2d by t. Okay. Now here, in this, if this is the velocity, we need time. First, I will write time from nickel, first one, nickel aluminum interface equal to 2 times d divided by v. So so I have written here what is the velocity of sound through nickel, which is 6.02 times 10 to the power 3. Also, I will write velocity of sound through aluminium, 6.25 times 10 to the power 3. So I have written the velocities. So here 2 multiplied by distance. How much is the distance here for nickel aluminum? That means complete nickel. 2.5. So I will write
2.5.
Yeah, times minus 3 to convert millimeter to meter divided by velocity through nickel. because even nickel aluminum interface, it is through nickel only. So we have 6.02 times 10 to the power 3. Can you calculate how much is the time from nickel aluminum interface? How much is the time from nickel aluminum interface?
0.8.
0.83.
8.3.
Yeah, 0.83 seconds, right?
Yes.
So this is the value. Times something must be there, right?
Yes, Doctor. 6 minus 6.
Minus 6 seconds. Okay, now the equation, the answer is complete. It is 0.83 times 10 to the power minus 6. So here what we will write? Here we will write 0.83 multiplied by 10 to the power minus 6. Is that clear? We finished the first one. Okay. Done?
Yes, done.
Now,
Yes, Doctor.
now we proceed to next material, which is aluminium. So aluminium nickel interface, correct? So I will write velocity, the time required for aluminium nickel interface equal to velocity. First step, I will write what time required for nickel aluminium plus
Nickel, aluminium plus aluminium, nickel.
time required for aluminium, right? To reach aluminium.
For the two phases.
Yeah, that means time required for the aluminium, isn't it? It is an interface. Aluminium nickel interface, we can say. Okay, because here I have written aluminium nickel interface. That's why I don't want to confuse here. That's why I put aluminium alone. Is that clear? So the time, I will explain to you, the time required to get a signal from aluminium nickel interface, that means from here, that is equal to time required through nickel plus time required through aluminium. Even if you want, I can remove the aluminium here, I can put nickel. That is better, right? Hello?
Nickel plus aluminium, Doctor.
Okay.
So, go, Doctor.
Yes. So this is time required for, already we calculated time required for nickel. How much? 0.83 multiplied by 10 to the power minus 6. Yeah. Plus time required for aluminium. We have time. How we calculate time? 2D by V. 2 times D. What is the D depth of aluminium? 4 millimeter. So 4 times 10 to the power minus 3 divided by V. V for aluminium, it is not 6.02 now, it is 6.25. So I will write 6.25 times 10 to the power 3. So how much is the answer? Hope that it is clear to you. So time required for ultrasonic wave to reflect from aluminium nickel interface, this is the interface, equal to time required for ultrasonic wave to travel through nickel plus time for the ultrasonic wave to travel through aluminium. That I have written here, time through nickel, time through aluminium. Nickel we already calculated here, this is for nickel, so we have written the same value here, plus 2 times D. D for aluminium is 4 millimeter divided by velocity of sound through aluminium, which is 6.25 times 10 to the power 3. Yes.
2.11 multiply or minus 6.
Minus 6 seconds. You can see here the answer 2.11 times 10 to the power minus 6, correct? So here what I will write? I will write 2.11 times 10 to the power minus 6 seconds. Okay, is that clear to you, all of you?
Yes,
Yes.
doctor.
Yeah, can you try the last one? What is the last one here? Backward echo. Backward echo. That means the signal coming from nickel, the backward. Can you try the backward echo? Can you try and give the values? Similar to this, can you calculate and try? I need to write some value here.
2.94 multiply 10 to the power minus 6.
Okay, so that is right. So how we got that? How we got the value? What we did here? So time required from, what I am going to write, time required from backward. You know what is backward? Equal to time required from nickel. What I should write? It is not, no need to calculate that. We can write time required from aluminum nickel interface plus, have you understood? This is aluminum. This is
Yes,
total
doctor.
time we calculated here. From we have up to here we have 2.11. Now we need to calculate only for nickel and add with the aluminum. See, time required for ultrasonic wave to travel from transducer till aluminum nickel interface we have, plus 2 times what is the distance for nickel here? 2.5 times 10 to the power minus 3 divided by 4 nickel 6.02 times 10 to the power 3. So this value already we have, which is a 2.11 times 10 to the power minus 6 plus 2 times 10 to the 2.5 times 10 to the power minus 3 divided by 6.02 times 10 to the power 3. Is that clear to you? So what I did, I took the time, time for the ultrasonic wave to travel from front to aluminum nickel interface. That means from here to here plus nickel. Nickel is this one. That is the same value, 2.5, 2 into 2.5 times 10 to the minus 3 divided by this. So your answer you are getting is
2.94 multiply 10 power minus 6.
So here I will write in the sketch 2.94 times 10 to the power minus 6. This is the answer. So now the question is complete. If you have any question, you can ask. This is how we get the signal from ultrasonic waves, and this is how we calculate the time, or this is how we sketch the time, etc. If you have any doubts in this, you may please ask. I can clarify.
It's clear, doctor.
Clear, right? Yeah, it's clear. So this is about the ultrasonic wave inspection system. Now let me ask you a few things. We finished some questions today, 2 questions. We have a lecture on Thursday, but Thursday we have a holiday, right?
Holiday.
Yeah. So maybe tomorrow I will continue with the lecture and I will try to finish the lecture, okay? I'm not sure if possible. I will try to finish the lecture tomorrow, or I may continue with the tutorial. Let us see. If I continue with the tutorial, Sunday I can finish the lecture, right? Okay. So what I will do, I will continue with the tutorial. If any equations are required, I will take it later, because we are going to continue with ultrasonic inspection on Sunday also, because we have to finish it. So we will be solving more questions tomorrow. Tomorrow also will be tutorial, and Sunday 3 to sorry, not Sunday, Monday 3 to 4, correct? If I am not wrong, it is Monday. We have a session on Monday 3 to 4. Monday 3 to 4 we will finish ultrasound. Is that clear? Okay.
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 Yeah, because week 3 I don't need much time to finish week 3, which is acoustic emission technique. I don't need much time. So ultrasonic I take more time, and even Thursday is a holiday. Okay, clear?
Okay.
Now I taught you 2 equations for calculating the velocity. If you remember those equations, just I wanted to show you only the equations of this, and those equations are available here in module 2. If you look at it in module 2, and here week 1 is our topic, which is ultrasonic inspection. Here in ultrasonic inspection, these 2 equations, if you see them, see these 2 equations. One is V, transverse velocity. Don't get confused. Transverse velocity means what? Transverse velocity, if you have a confusion, I will change it as shear velocity. Shear velocity equal to square root of G by rho. Do you remember we did in torsion experiment, we rotated a component and it broken, and I gave you some data in Excel. You drawn a graph. Do you remember that experiment we did in strength of materials? In a machine, that machine one chuck rotates, we apply shear stress and it breaks. When it breaks, we take the specimen out. You can see how much it will get rotated. And then I gave you one Excel sheet. You calculated modulus of rigidity. Do you remember? Last
Yes, doctor.
yeah, semester 1 in last year. So this is just to calculate G, modulus of rigidity, just remember. So modulus of rigidity is G, which is a material property, divided by rho, which is related to shear. That's why shear velocity can be calculated using this. Longitudinal velocity by VL equal to square root of E times 1 minus mu. It is directly depend on a linear, not shear. That's why modulus of elasticity, mu is Poisson's ratio and rho is density. So these 2 equations are basically used for calculating shear velocity and longitudinal velocity. But remember, they directly dependent on the material properties. So that's why they are constant. Why longitudinal velocity for nickel we wrote 6.02 and for aluminium 6.25 constant? Because E for aluminium is constant, mu is constant, rho is constant. Similarly, shear velocity also constant. Is that clear about velocities?
Yes, doctor, clear.
Yeah.
Yes.
So
doctor.
for the today I will stop, and we will continue our studies in the coming class.